Put down a washer, you put down a wet piece of paper, and you put down a penny.
Wait, just wait.
I get it.
Okay?
I get it.
So, washer, paper, penny.
Washer, paper, pen. Washer, paper.
And, I still find it remarkable that you can do that, and that there's nothing magical about these, that the chemistry in these can be directly reproduced by stuff in the kitchen. And that it took until 1800 for somebody to figure that out.
How will you get the battery to press on without people touching it? Do you have a solution for that?
Well, there's a couple of solutions. You could tape it on. You could use a rubber band, like this one. I have a little rubber band. Instead of a wire, I use a bit of foil, which we know conducts electricity.
Okay, that's a good.
And
that's
then
one.
you can make a little flashlight out of it.
That's cool. That's kind of cool. I like that idea.
This is a negative sign, which means this is the negative terminal of the battery, or the place where electrons come from. And they come out of the bottom of the battery. So think of the battery as a lemon, and think of this end as the washer, right? That we stuck into the lemon. Electrons come out of here. They run down the wire. They run into the light. And there's a little wire inside here that the electrons run through. But because it's really, really thin, if you hold it up to this light, you can see that there's a really tiny wire. Because it's so tiny, when the electrons flow through it, they bang around enough to heat it up. And then it goes back in the positive terminal of the battery, where that was the copper part of the lemon, and inside the battery is lemon juice, or a paste which allows ions to flow through it, which works the same way as lemon juice or vinegar.
That's kind of cool.
And when we chained the lemon together, we made a big loop that the electrons could flow through. But this battery, the outside skin of this battery is probably made of zinc, which is made of the same stuff that this is made of. So that's a battery, and that's a battery. I want the kids to recognize sort of emergent properties of simple things. You stack pennies and zinc together and you get electricity. Right? The complicated consequences come from arranging simple things in novel ways. And that also to be able to look at a lemon, which is not, it's not a very practical form factor for a battery, and make this functionally the same thing that is much smaller just by using a penny and a zinc washer. It's nice to be able to get the kids to connect with it. It's got a nice physicality to it because they can play with things and touch it and taste it. There aren't many experiments in chemistry and physics that are that much fun and also that fundamental to science and chemistry. Okay, so we had it sitting on a foil base. Remember, from the aluminum foil. We put down a washer, which was made of zinc, a piece of paper that was wet and it was covered in vinegar, and then a piece of copper, which was a penny, on top. And every time we made one of those, it was like making a lemon. And if we look at these two diagrams, the zinc is here, the zinc washer is at the bottom. The wet paper with vinegar on it is the same as the lemon. So we replaced the whole lemon with a piece of vinegar wet paper. And then instead of having a copper wire, we used a copper penny to make. So this cell, copper, paper, zinc, is the same as this lemon. Copper, lemon, zinc. I spent a lot of time putting aluminum foil on batteries and fiddling and making that sort of stuff. And it was an entirely new order of making things where before you would build things with Lego or Meccano and you get a thing. Here you would build it with wires and tape and batteries, and the thing would have, when you built it, would have a life of electricity rather than just being static. I don't think they'll think about a lemon without thinking about it as its potential as a battery, and if they put their tongue on a 9-volt battery years from now, they'll think of lemons and think about juice. So that was I think that's a great place to start. And I think over time that if they revisit building voltapiles and other things, they can start to use those to drive other experiments. I look back on things I remember and things that really taught me something about how the world works, and it was these kinds of experiences which, even though I may have forgotten the subtleties of how things work, I'll never forget that I can make a battery out of a lemon, right? And I'll never forget that something to do with two different metals in a juice or a salty water or an acid is the fundamentals of how chemical batteries work. And I think this is pretty well calibrated to kids this age. I've seen older kids do this, but I was a little bit concerned that just construction and those kinds of things wouldn't work, and they would have trouble with the meters. But everybody seems to be okay with that. Luckily it was made in phases, so we can make the lemons first, and then we can make the voltapile, and then we can move on to the other battery. So it was reasonably well segmented. So I guess, I'm used to calibrating to adult audiences with other subjects, and they have they tend to be in our dimension of work,